We're going to start with what a wave is. And a wave is a disturbance of some sort that carries energy and it travels. It travels like this, and it can travel through matter or space, depending on the kind of wave it is. And there's different kinds of energy that travel this way. Light is an example of a kind of energy that travels in the form of waves. Sound is a kind of energy that travels in the form of waves. And so when you talk, you produce sound waves that travel through space, and then you can hear the effect of them somewhere else. And just recently, we've also been learning about seismic waves and how when there's an earthquake, for example, that energy that was present travels through the earth in the form of waves. Refraction is when a wave bends because it hits something different. That something different is often referred to as a medium. So if my wave, which recall a wave travels like this, well, because you can't actually see energy traveling in the form of waves, I'm just going to make a line instead. So let's say my wave is traveling in a straight line headed somewhere. And then all of a sudden it hits a different kind of medium. Like maybe we go from air and then we hit water, for example. Those are different mediums. They're different environments. Well, my wave bends a little bit when it hits that different medium. So instead of traveling this direction, it bends just a little bit because it hits a different medium. Now, an example of that is light. Light bends when it hits a glass prism. And so here, you'll see light is traveling right here. It's going through air or space. And when it hits this piece of glass, all of a sudden, those light waves bend. And turns out, when you bend visible light, you get all the different colors of the rainbow over here: red, orange, yellow, green, blue, indigo, and violet. Well, light does this, but seismic waves will also do this. When seismic waves hit a different medium, they will bend. Let's see, different mediums for seismic waves might be something like a different kind of rock. Maybe it's a material with a different density. Density is how closely packed the particles are inside of a substance. So maybe it hits a different density and it bends a little bit. Maybe the state of matter changes a little bit. We go from something that is very solid to something that's solid but a little gooey, like the asthenosphere. So here you'll see rock type 1 is listed up here on top. Rock type 2 is listed down here on the bottom. And this just shows the seismic wave coming in, and you can see when it hits the second rock type, its path changes. Same with over here, and you can see it's a little more dramatic. Rock type 1, rock type 2. And as rock type number 1 is, as the seismic wave is coming in for rock type number 1, it then changes its path when it hits rock type number 2. And it deflects, and then it also changes its velocity. So it can speed up or it can slow down depending on the material that it's going through. Reflection is different than refraction. Reflection is when a wave bounces back because it hits a different medium. So here, let's say it's light and it's traveling, and then it hits an object or a different medium. And in this case, it doesn't reflect, it doesn't go through and bend, it completely bounces back, it reflects. A mirror works by reflecting, right? You look into a mirror and what you see is your reflection. You bounce back to yourself. Sound waves can also bounce off of something, they can reflect and come back, and then you can hear an echo. And so you probably heard this before. Let's say you're standing here, and let's say there's some big object over here, and you begin to yell. Your sound waves travel out, and then they hit that object and they bounce right back. They reflect. And then they come right back to you. I'm going to make those in a different color so that they show them coming back to you better. And they come back and you can hear your voice once again. So your echo is really an example of sound waves reflecting off of something. Here's an example if we're thinking of seismic waves. Remember, seismic waves are energy that transfers throughout the earth. And so this line right here represents a seismic wave traveling through rock 1. And you can see that when it hits rock 2, some of this wave is reflected. It just bounces right off and back up. You can also see there's a little bit that is refracted also, where it bends and it still goes through rock 2. So this wave is refracted, whereas this wave is reflected. Now if you look at this diagram at first, it seems very, very busy. But what we're looking at here is right here, there is an earthquake, and seismic waves are traveling in every direction from that earthquake. They don't even show all the seismic waves. There's so many of them, but they're traveling in every single direction. And you can see that they're behaving differently depending on where they're going throughout the earth. And so we can see with this key over here that this blue line represents a primary wave. So it turns out there's different kinds of seismic waves, and one of them is called a P wave or a primary wave. So if I look at this primary wave, I can see it's traveling through this material. I can see that when it hits right here, some of it is refracted and it bends a little bit. Oop, and then you can see right here, it bends a little bit again as it goes back through a different kind of medium. So every time it's hitting a different color, it's hitting a different medium. So here it hits a different color, it refracts, it hits the mantle layer again, a different color, and it refracts and bends a little bit more. Here you can see the same thing going on when it hits this area. Some of this is refracted and bends out like that. And these S waves, those are called secondary waves. They're another kind of wave that happens when there's an earthquake. They're also traveling, and you can see them traveling through. You can see that they actually, when they hit the outer core right here, they just completely stop. They can't even travel through the outer core. Now, one of the reasons for that is because it turns out secondary waves can't travel through liquids. So when they hit a liquid of the outer core, they just completely stop. Now, as a result of looking at how these seismic waves travel through the earth, we get an idea of what's inside the earth. So the fact that I don't see any secondary waves, any of these purple S waves over here, tells me they went through something, or I should say didn't go through something inside the earth. Something stopped them. We know that that's a liquid layer. Because I see an earthquake here, but then I also feel a lot of shaking over here, some of this, the seismic waves hit a layer and then kind of bounce off. And here's one where it's kind of reflecting a little bit. It hits this and then kind of bounces off. And over here I don't really feel anything because these P waves here got reflected or refracted, and so this is, they call it a shadow zone. It's like being in the shadow of a tree. You can't really feel the light or see the light. In this example, the primary waves, there's a shadow here because the primary waves are being reflected and refracted and they don't ever hit here. And so depending, having seismograph stations all over the earth and collecting information from where primary waves travel and where S waves travel and where they don't, we've been able to figure out what exactly is going on inside the earth and what layers are composed of.